Let's try to solve these linear homogeneous equations. They are given us 4 equations. Okay, so what is the first step? Write them in the form of ax equal to 0. So a is this and x is 0. This is fine. And the second step is try to get it into echelon form. So why echelon form? Because we want to find out the rank. Why rank? Based on the rank we can find out whether solutions exist or not, or unique solution exists, or infinite number of solutions exist. Let's see this. So now using this element, the first row, first element, I want to make all these elements as zeros, right? But then it is 3, so in order to make it I might have to multiply and divide and apply some more operations. But if you observe this row 4, it is already having 1 here. So if I could take it to the first row, place of first row, if I can exchange these two, then it will be easier for me to make all the remaining elements 0 directly. You need not do that. You could even use this 3 and make all of them zeros. It is up to you. I feel this one as easy method. So now I am just exchanging R1 and R4. Yes, I got this. Now using this particular element, I'll be making all these elements as zeros. For that reason, I am applying these transformations. Okay. See, from this one, I got this one by applying these transformations. Okay. So what are the transformations? From from this R2, I am subtracting 2 into R1, and from this R3, I am subtracting 2 into R2. And from this R4 I am subtracting 3 into R1. That is what is done here. Then I get all these elements as zeros, if you observe it. Right? And what is next step? I want to use this particular element and then make all the elements below it to be zeros. That is what I wanted to do. Now again the same thing. I'll be comfortable if this element is 1, or if this one is a scalar multiplication of this one. That way it will be easy for me to make it as 0. So for that reason I'll try to make this element as 1. Even if you observe this entire row is a multiple of 3, right? All the elements in this row are multiples of 5. Therefore, and again the same thing is with this, all the elements in this row are multiples of 5. So what I'll try to do is, I'll try to divide this one and this one with the corresponding numbers and put the result there. So I want to divide row 2 by minus 3 and row 3 by minus 5 and row 5 by minus 5. So that is what I did. Now if you observe it, so see, on this one, on this particular matrix, I applied these transformations. Don't get confused. On this particular matrix, I applied these transformations and I got this matrix. That is the convention I used in this example. Earlier I used to write these transformations above it. Now I am just writing it side by side. Okay. And now using this element, I want to make all these elements as zeros. And fortunately you can observe that even these two elements will also become 0 if I try to subtract it. If I try to make these two zeros, even these two elements, these 4 elements will become zeros. That is what has happened. See, now from R3, from this one, I am subtracting R2, I am subtracting this one and replacing it here. Then I get all zeros. From R4, from this one, this row 4, I am subtracting row 2, which means this one. Then I got this. Right? So I got these two. Now if you observe this is in echelon form. This is in echelon form, and we can say that the number of non-zero rows are 2, and so the rank of this matrix is 2. If you are not able to find it out, if you are not able to know when to stop, when did we get the echelon form or not, whenever you get a row as 0, you just stop there and observe it. If you can find any 2 by 2 or 3 by 3 squares of matrix whose determinant is not equal to 0. In this case, it is clearly a 2 by 2 squares of matrix whose determinant is equal to is not equal to 0. Therefore, the rank is definitely not less than 2. Okay? Can it be greater than 2? If it has to be greater than 2, then you are supposed to go for 3 by 3 matrix. If you take any 3 by 3 matrix, if you try to form any 3 by 3 matrix from this, definitely one of the rows is going to be zeros. You try anything. You try to take any 3 by 3 matrix anywhere. Okay, any 3 by 3 matrix, definitely at least one of the rows is going to be zeros, and so no 3 by 3 matrix will have a non-zero determinant here. That is why the rank cannot be 3. So what is the next one? Rank would be 2, because we are able to find it out here. It is a diagonal matrix, and not diagonal, triangular matrix, and the determinant of this 2 by 2 matrix is 1. Therefore rank equal to 1. Now what can we say? Rank is obviously less than number of variables, so number of unknowns. Therefore we have n minus r linearly independent solutions. How many linearly independent solutions? N minus r. So since we have n minus r, whenever we have this r is less than n, the general procedure is we have n minus r linearly independent solutions, and in order to find those n minus r linearly independent solutions, the procedure is to make n minus r variables to be assigned some random values. So what is n minus r here? N is 4, r is 2, n minus r is 2. Therefore 2 variables among these 4 variables x, y, z, w. 2 variables among these 4 variables will be assigned some random values, and after assigning random values to 2 variables, we'll find out the other values in terms of these values, these random values. That will form the general solution. Okay. Now see this. So the system is originally having 4 equations, but after the transformations we are left with only 2 non-zero rows. Therefore the system of 4 equations can now be written as if it is a system of 2 equations. So now the entire system is equivalent to this. Okay, and I have to solve this for the values of x, y, z and w. So you can take any 2 unknowns and you can assign them some random values, any 2. It is not that you have to take w or x, you can take any 2. So what I am trying to do is, I'll try to take z as c1 and w as c2. I am assigning random values to these two unknowns, and from these unknowns I'll try to find out the values of the remaining variables. Now we shall see that. Let's just continue to solve the previous equations. Earlier I have given you 4 equations, and after the echelon form we got these 2 equations, and both are equivalent. Now using these 2 equations I am trying to find the values of unknowns. Now z and w, as I just said, are assigned to c1 and c2. Now using this c1 and c2 I want to find out the remaining. For that reason I am going to write the remaining variables x and y in terms of z and w, and then I'll substitute in place of z and w c1 and c2. See this. Now from this equation, from this equation I can write y equal to minus 8z minus 3w. That is what I wrote here. Y equal to minus 8z minus 3w. And from this equation I can write x as x equal to minus 3y minus 13z minus 4w, right here, minus 4w. Okay, and then in place of y I am substituting minus 8z minus 3w. In place of y I am substituting minus 8z minus 3w. Then I got this, which means both x and y are written in terms of w and z, and we already know that w and z are equal to c1 and c2. So I am going to substitute here. Finally I got this. So what does it mean? 2 of the unknowns are assigned. Why only 2? Because n minus r. N is total number of unknowns is 4, and the total number of variables is, rank of this is 2, right? So 4 minus 2 is 2, which means 2 variables have to be assigned some random numbers, and from those we are supposed to find out the other variables. That is why I have chosen z and w to assign the random numbers, and from this, in terms of z and w, I expressed all the other variables, all the other unknowns, and then I found out the solution. So how many solutions will be there? C1 and C2 can take any value, any integer, any number. So C1 and C2 can take any value, including zeros. Therefore what happens is, for every value of combination of C1 and C2, we get one solution, and that solution will satisfy the given equations, right? For example, if you put C1 equal to 1 and C2 equal to 1, let us assume that we are putting C1 equal to 1 and C2 equal to 1, then what happens to this? X becomes 18, right? And this one becomes minus 11. If I put here 1 and C1 equal to 1 and C2 equal to 1, then one of the solution is x, y, z, w will be equal to 18, minus 11, 1 and 1. Now if you take these solutions and substitute in the original equations, then you are going to these solutions are going to satisfy it. Similarly, you can put C1 equal to 2, C2 equal to 2, or C1 equal to 1, C2 equal to 2. Likewise, you can substitute infinite number of numbers in place of C1 and C2, and you will get infinite number of solutions, and all these solutions are going to satisfy the given equations, right? Therefore, whenever n is less than r, the number of solutions are going to be infinite. Okay, so we shall see more examples, you'll understand.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.